At this point, we're ready to document the area with secondary electron micrographs. Let's re-enter the SEM menu by pushing function key number 17. We can see that we are back at the electron gun parameters that were our initial settings, but once we leave the SEM menu and then come back into the SEM menu, they now become our previous settings. We need to, at this point, determine at what beam voltage we want to do the analysis on the sample. And at that beam voltage, we will set up for the secondary electron micrographs. This sample may cause some charging, so what I would like to do is obtain the data using a beam voltage of 15 kV. We'll then press function key number 9, which will allow us to change our beam voltage, and type in 15. When changing the beam voltage, the most critical parameter to monitor is the emission current. This is monitored on the high voltage gun supply located in the second bay below the digital gauge control. If we enter the 15 kV, we will see our high voltage go from 3 to 15. And depending upon the high voltage gun supply, this emission current can either display a drastic change in emission current, or as we see with this gun supply, there has been very little change. The goal is to keep the emission current around 100 microamps. To do that, we slew our emission voltage, which is function key 16. Slewing the voltage up will bring our emission current down, and we will monitor that emission current until we get approximately 100 microamps of emission current. Now that we have the desired emission current at 15 kV, let's read our beam current. To do that, we press function key 15 and toggle the beam current reading on. We see we have a beam current of approximately 300 nanoamps. Our goal to get the best beam size is approximately 0.1 nanoamps of current. So we need to decrease the current by quite a bit. The easiest way to begin is to change the objective lens aperture. Right now we are on the 16 mil aperture, so we can monitor the current as I change apertures. We now have the 8 mil aperture, and notice we have decreased the current to 68 nanoamps. I have now gone to the 4 mil aperture, and we now have a current reading of approximately 20 nanoamps. The smallest beam size is typically obtained using the 4 mil aperture, so we will leave the objective lens aperture set in the 4 mil aperture. To now decrease the current, we need to change the condenser lens. We can press function key 14, which will then allow us to slew the condenser lens up in order to close the condenser lens and decrease the current. We now read less than 1 nanoamp of current. the current reading circuitry which we are using is accurate to 1 nanoamp, so anything below 1 nanoamp we will have to measure with the external ammeter. So let's toggle the beam current reading off by pressing function key 15 and toggling the cursor to the off position. Before connecting the external ammeter, we want to first toggle our electron beam off. What can happen is whenever connecting or disconnecting the absorbed current preamp box, if there is any charge buildup on the stage due to the electron gun being on, you can damage the preamp box. So whenever that preamp box is either connected or disconnected, make sure that first the beam is toggled to the off position. We can see now that the beam is on. We also, on our status line, can see that the electron gun is on. To toggle the beam off, we press function key number 8. We toggle it to the off position, and immediately when we toggle to the off position, notice that our electron gun status line will update saying that the electron gun is off. We now have it off, and the status line tells us that the electron gun is off. Once we have the electron gun off, we can then disconnect the absorbed preamp, and we can connect the external ammeter. To connect the external ammeter to the target of the specimen stage, we first want to make sure that the input from the ammeter is connected to the BNC connector on the back of the bias box marked ammeter. Also on the back of the bias box there's a BNC connector marked target. We want a BNC cable connected there. We want our first toggle switch, which is labeled absorbed and ammeter, to be on ammeter, and our second toggle switch, which is labeled ion and target, to be switched to the target mode. We also want the black switch to be on plus 90 bias select. We are now ready to uncable the absorbed preamp box, which is cabled to the target, and now cable the external target lead to the specimen stage marked target. We can now turn the external ammeter on. We do want to be reading in the range of nanoamps, which we have here. We can see that we are on the proper range, being nanoamps. Again, we have no current right now to the specimen stage. So this is our background current. We want that to stabilize. Once it stabilizes, we can go back and turn the beam on using function key number 8, toggling the beam to on, remembering that our background current is 0.4 nanoamps. We would like a current of approximately 0.1 nanoamps, so we want to slew our condenser lens and change the current to approximately 0.5 nanoamps. Turning the beam on, we see that we are measuring a current of approximately 3 nanoamps. We want to change that again by slewing the condenser lens using function key 14 and slewing the condenser lens to decrease the current. Again, we want approximately 0.5 nanoamps of current. That will account then for the 0.4 nanoamps of current background signal. .55, 0.54, and 0.5 nanoamps. To check the background current again, let's go to our beam using function key number 8 and toggle it off again. We see now that our background current is a little bit lower, so we have 0.13 nanoamps of current. What we can do is turn the beam back on, go back to condenser lens of function key 14, and slew to 0.47 nanoamps. Go back to function key 8, toggle the beam off. We now have approximately 0.11 nanoamps of current. Toggling the beam back on shows us that approximately 0.1 nanoamps of current. At this point, we are ready to toggle the beam back off using function key number 8 and reconnect the absorbed preamp cable. With the electron gun now off, we are ready to disconnect the target lead from the battery box and reconnect the target lead from our absorbed preamp box. We now have the correct current for SEM images. Let's go back to the TV monitor and fine-tune the beam to obtain the smallest beam size. At this point, to obtain a TV image, we first need to toggle the electron gun back on. By doing that, we go to function key number 8, toggling it from the off position to the on position. Then we can press soft key number 2 in order to activate the auto video. We are now automatically setting the multiplier, contrast, and brightness in order to give us a TV image. We can also sharpen the focus by pressing soft key number 10 and slewing the focus until we get a sharper image. We now have a sharp image at this magnification. Let's increase the magnification. By slewing the magnification, we now have a magnification of a little over 1000x. We can now also press soft key number 2, reactivate the auto video. It will then again very quickly give us a good contrast, resetting the SED multiplier, gain, the brightness, and contrast. We can also once again sharpen the focus using soft key number 10. This is a coarse focus using soft key number 10. We also have a fine focus control knob, which is located at the right of the tabletop where the keyboard is sitting, where we can go out of focus and bring it back into focus in order to more accurately define where the focus should be set. Again, that's using the fine focus knob located at the right of the keyboard tabletop. Let's increase the magnification. Looking at an area in here, moving the specimen stage, determining exactly what area we would like to do the analysis simply by observation. We can again refocus. What we are noticing on this TV image is a double image. Not all electron gun filaments will operate exactly the same. Most electron gun filaments operate with an optimum emission current set at 100 microamps, which is where we have our set at this time. Some filaments operating at that emission current will have multiple emission points. This filament in the electron gun has multiple emission points. We can see double imaging. What we have done previously is we have determined at what emission current setting we can eliminate the double imaging and operate efficiently. Again, since we have done that previously, I will enter that value by first pressing soft key number 16, which will allow us to change the emission voltage, and enter the value which I know to be the optimum emission current setting. We have less current at this time, so once again we will press soft key number 2, activating the auto video. At this point, we would need to recalibrate the current to the sample using the external meter. I have already done that and have obtained the desired 0.1 nanoamps of current. We now want to more clearly define the exact area and magnification where we want to do the analysis. On this sample, I would like to do the analysis at a magnification of 5000x, so I will enter that magnification. We can then move the sample and position it where we would like in order to do the analysis. I would like to include this part of the circuit, this part of the circuit, and of course the spaces in between. At 5000x, we can easily see 3 of these bars, so we will include them in the analysis, and specifically this area. We can utilize the image rotation function using function key number 6. We can rotate the sample from 0 to 360 degrees. I would like to utilize this rotation capability in order to square up the image. For ease of analysis, let's slew the rotation. What I would like to do is rotate in the other direction, that is using the up arrow located in the lower right corner of the keyboard. And again, to square up the image, what I mean is to have these lines run perpendicular. Something like that. Let's sharpen the TV image by utilizing the fine focus control. We can overfocus and underfocus. What we would like to do is get the best focus using the fine focus. Then what we can do is, utilizing the stigmation correction, by pressing function key number 11, we can now slew both the X and Y stigmators in order to round the beam. Holding the shift key, I can then slew either the left-right arrows or the up-down arrows. Notice I have now slewed through the optimum focus. The easiest way to set the stigmators is to obtain the best focus by changing the stigmator. There we have a sharp focus. We have now gone through that focus again, so we will get the sharpest focus, enter that value, and then use the other stigmators, and again slewing through the optimum focal point and then slewing back to the best focus, we can then again use the fine focus knob in order to sharpen the image. To further optimize the beam size, we would like to steer the beam down the magnetic center of the electron gun. To access the voltages on the steering plates, we need to go to page 3 of the SEM menu. To do that, we press soft key number 6 to go to Next menu, which will take us to SEM menu page number 2, and pressing soft key number 6 again allows us to enter the 3rd page of the SEM menu. And we can see that now we have access to the electron gun calibration automation, the condenser steering, and the focus steering voltages. Function key number 3 will start the rocking of the condenser lens and will then allow us to change the voltages on the X and Y steering plates. Function key number 6 will activate the rocking of the objective lens, and we can then access and slew the voltages on the X and Y objective steering plates. We'll begin by changing the voltages on the condenser steering plates. The easiest place to start is at a magnification of roughly 2000x. So by pressing function key number 2 and entering a magnification of 2000, we now have this image. Pressing function key number 3 activates the rocking of the condenser lens. Notice that we see movement of objects in the TV image. We have corrected for the magnetic field and have found the magnetic center of the electron gun when we minimize the movement. So what we will do is slew first the X value, we can see now that the rocking is worse, so we will then slew the X value in the opposite direction. And we have now minimized movement in the X direction, but we see that we have movement now in the Y direction. We will now slew the Y value to try to minimize that movement. The easiest way, once again, is to go too far and to see whether it gets better or worse. We now see that there is more movement, so we will slew the Y value in the opposite direction. We now see it getting worse again. So we will slew to minimize that movement. We now see very little movement. It would now be easier to correct for this slight movement that we are seeing at a higher magnification. Going back to function key number 2, we'll stop the rocking of the condenser lens, allow us to activate magnification. Let's enter a magnification of 10,000. Position a feature to the center of the screen, and now reactivate the rocking of the condenser lenses with function key number 3. Notice it is much easier now to see the movement. Again, it looks more in the X direction. Notice we have now corrected for most of the X movement. We also do not see much movement in the Y direction. What we are seeing now is simply a rocking in and out of focus. This now tells me that the condenser lens steering plates are at the correct value. We are now ready to correct for the objective lens steering. To do that, we will go back to a magnification of 2000. Striking function key number 2 will again take us out of the condenser lens rocking. Activate magnification, enter a value of 2000. We can now activate the rocking of the objective lens using function key number 6. We see that most of the movement here is in the Y direction. So let's begin with the up-down arrows in order to change the value of Y. And let's also use the shift key so that we can do it rapidly. It looks like the rocking is worse in that direction. So let's go in the opposite direction. Looks like it is better, much better here. Now what we can do is move the sample using the Y micrometer on the specimen stage, bringing it back to the center of the screen. We will now slew using the up and down arrows without the shift key so that we can slew in smaller steps. Again, trying to minimize movement. Once again, it appears to be getting worse there, so we can go back to a value somewhere in here. Maybe a little bit of movement in the X direction, so let's use the left-right arrows. Worse in that direction, so we will now use the opposite arrow. Again, we now see more of an up and down movement, so once again using the up-down arrows. We now see a much smaller up-down movement. Slow a little bit further. Now we see more left and right. Very similar to using the condenser steering values. What we will do now is, since we have minimized most of the movement, to more fine-tune, let's change our magnification once again to 10,000x. Pressing function key number 2 will exit us from the objective lens rocking. We can enter a magnification of 10,000. Let's also use the fine focus and refocus the image. Let's also recenter the image using the XY micrometers. Pressing function key number 6 reactivates the rocking of the objective lens. And once again, we want to slew to minimize the movement. We have now pretty much eliminated the left-right movement. We have some slight up-down movement. which we have now pretty much eliminated. Notice that now the sample is rocking mostly in and out of focus once again. We now have the electron beam steered using the objective lens steering plates. We can now increase the magnification in order to obtain better focus of the image. Pressing function key number 2 will stop the objective lens rocking, activate the magnification. Let's increase our magnification to 30,000 and use the fine focus. We see now that the beam is still a little bit stigmatic, so we want to change the stigmatism correction values. They are located on page 1 of the SEM menus. So by pressing function key number 5, we can go to the previous menu, and pressing function key number 5 again brings us back to page 1 of the SEM menus. Stigmation is function key 11. Now by slewing those values, again we want to sharpen our image. And using the objective lens focus, we can then refocus to obtain the best image. Let's return to a magnification of 5000x. And realign the area for analysis. When doing Auger analysis on this sample, we want all of our maps and multiple points to coincide with the SEM images which we are about to generate. So what we want to do is make sure that we can duplicate this exact same area. To do that, what I like to do is make a registration mark on the TV screen utilizing one of the features and just tracing it so that I have both a reference point in the X direction and the Y direction. When we change current, we will see a slight shift or an apparent shift in the sample. It is actually a shift of the electron beam. And what we will want to do is be able to re-register every time to the exact same position, again, so that we can coordinate the SEM images with the maps, the line scans, and the multiple points. So now that we are setting up for a photo, let's make this registration mark so that we can be consistent and reproduce the exact same area. To document this area, let's begin with a lower magnification photo of the area. Let's start with a magnification of 200x. Before we actually acquire the photo, we should at this point activate the auto video by pressing soft key number 2. This will once again give us the optimum multiplier voltage, contrast, and brightness, which will then give us the best SEM image. To set up for a photo, we need to exit the SEM menu using soft key number 8, which then returns us to our home bank, and we need to press the setup photo key, which is function key number 20, using the shift key and then pressing function key 20. That allows us to get into the setup photo menu, where we can then define what we want included on our photo. Let's take a look at the fields which we can toggle on and off and include in the photo or decide not to include. Function key number 1 allows us to toggle the date on and off. Function key number 2 allows us to toggle a photo number, that photo number being entered using function key number 3. Right now our photo number is set at 59. We can change that on this particular sample. Let's begin with a photo number of 101, making sure now that the photo number is toggled on. Function key number 4 allows us to toggle our beam voltage on or off. That voltage is read from the SEM menu, so it knows what beam voltage the electron gun is set at right now. We can, using function key number 5, toggle the magnification on or off. At this point, let's toggle it on. Function key number 6 toggles the micron marker on. Function key number 7 allows us to toggle comments on. Function key number 8 allows us to enter comments. This is a microwave transistor. So we will add that comment to our photo. Function key number 9 allows us to toggle selected areas. Function key number 10, selected lines, and function key number 11, map areas. Since we have not chosen any areas for analysis or lines or map areas, we will leave those toggled off, and we will demonstrate those later. To demonstrate how the photo will look, we can go to our TV monitor. I have toggled all of the fields off so that I can demonstrate how they look when we toggle them on. We will be able to see them superimposed on our live TV image. Going back to function key number 1 and the date, I will now toggle the date on. Function key number 2 toggles the photo number on. Function key number 4, the kilovolts. Function key number 5, the magnification. Function key number 6, the micron marker. And function key number 7, the comments. We can also annotate the photo by using the soft key number 2, labeled DSM Text Annotate. By pressing that, we then enter the DSM Annotation menu. Function key number 1 will allow me to change the font size, or the size of the text with which we will type on the digital storage monitor. And function key number 2 allows me to slew to a cursor location on the DSM, where we will then be able to enter the text. The cursor on the digital storage monitor looks like this, giving us a cross. What we can then do is, using the shift key, we can slew in the X direction or Y direction very fast. Without the shift key, we can slew more slowly. Once we reach an area where we wish to enter the text, we then utilize soft key number 3 to enter text. It then eliminates the cursor and allows us to type with the correct font size. What we will do here is simply type sample number 1 just for demonstration. Once we are finished typing the text, we must then return to enter the text using the escape key on the typewriter keyboard. We can then return to the previous menu by pressing soft key number 6. Taking a photo right now, we would obtain all of the fields which we have turned on, including the digital storage monitor text annotation, which we have labeled as sample number 1 for this demonstration. We can also take photos from the SEM menu. If we were to take a photo in the SEM menu using the soft key labeled photo on page 1 of the SEM menu, any of the fields which we have turned on in this photo setup menu will remain on in those photographs, except for the digital storage monitor text annotate. Only in the setup photo mode can we access the DSM text annotate. We are now ready to obtain a hard copy photograph of the TV monitor image by pressing soft key number 1 labeled photo. When we do that, the computer responds with the message open shutter, strike enter to proceed. At this point, we want to open the shutter on the camera to our photo storage scope. We can then strike enter on the keyboard, and the computer responds with exposure in progress. Please stand by. If we were to look at the TV at this time, we would see that our live image has been frozen, but it is being replaced with the high-resolution TV image. This is now the photograph that we will receive. Notice much sharper features as we scan slower. In the photo setup mode, when we take a photo, the time is 50 seconds per frame. We can now see that the photo has finished and we have returned to a live image. The computer then responds with the message close shutter, strike enter to proceed. At this point, we can close the shutter to the camera and develop the film. When the photo is completed, the computer responds with close shutter, strike enter to proceed. When we strike enter, we then return to this menu, which allows us then to change our fields, turning them on or off. And also we could add more DSM text annotation and redo a photo. Striking enter after closing the shutter will also, on our TV monitor, update our photo to the next photo number, so that next time we take a photo it will no longer be 101, but it has now updated to 102. At this point, we could exit the Setup Photo menu by pressing soft key number 8. And what that does is it will also erase all of our DSM text annotation and any of the fields which we had turned on. We are now back to a live TV image. And on the computer, we see that we have returned to our home bank. To prepare for the next photo, we need to re-enter the SEM menu by striking function key number 17. We should also increase our magnification to the same magnification where we registered on the TV monitor. That was a magnification of 5000x. To re-register, we can then use the image shift, which is function key number 3, and we can move in the X direction and in the Y direction using the arrow keys located in the right corner of the keyboard. Once we have the sample registered with our registration marks, we then want to make sure it's in focus, again using the Find Focus knob located at the right of the tabletop where the keyboard is sitting on. While we are observing this at a higher magnification, I would also like to demonstrate a couple of other features. They are located on page 2 of the SEM menu. To get to page 2, we will press soft key number 6, which will then take us to the next menu. What I would like to demonstrate is the scan rate. We had talked previously about using the photo soft key, which was soft key number 3 on the first page of the SEM menu. That will take a picture of whatever is on the TV at the time. It will freeze that image and take a photograph of that. What I would like to demonstrate is how we can get better photographs utilizing that key by changing our scan rate. Pressing function key number 11 will allow us to toggle our scan rate from fast to medium and then to slow. Using this sample at this magnification, it will be very obvious when we change the scan rate as to the resolution that we will see and the detail that we can see by changing scan rates. This is a TV image using the fast scan rate. By toggling to the medium scan rate, we can see more detail. We obtain a sharper image. By then toggling to the slow scan rate, we can obtain even a sharper image. In the photo setup mode, I had mentioned that when we take a photo in that mode, it takes a 50-second scan to acquire that data. So we get a high-resolution SEM image similar to this one. But in the semi-perms, the slow scan rate at which we are scanning now is 6.7 seconds per frame. So if we were to take a photo using the scan rate slow to give us this TV image, the actual scan rate of that photo would be an image using 6.7 seconds per frame. Whereas using the setup photo routine, we would spend 50 seconds per frame, which would give us an even higher resolution picture. We can also demonstrate what is happening when we activate the auto video mode. Let's change our scan rate back to a fast scan rate. And now we can go to video calibrate mode using function key 14. And let's be sure that it is in the video calibrate mode image. We can now activate video calibrate by pressing soft key number 4. And what we see on the TV is a little bit of red located on this left side of this pad, some red here and some red here, and a little bit of green located here and here. What this tells us in the video calibrate mode is that we have a little bit of very bright signal or very high signal and a little bit of low signal. Anything that is green in this image, in the image video calibrate mode, will be the blackest black on our photograph, and anything that is red will be our whitest white. These are the parameters controlled by the auto video: our contrast, fine brightness, coarse brightness, and multiplier voltage. What we can do is, as we monitor the TV image in the video calibrate mode using the image video calibrate and change the brightness and contrast, we can see how we can affect the image which we get for a photograph. Again, notice we have a little bit of green and some red. By changing the contrast using function key number 5, I can slew the contrast up. Now we have a lot of brights and no blacks in that particular image. I can then slew the contrast back and go down. Now we have a lot of blacks and no whites. We can also change the brightness control using function key number 6. Slewing that up, you see now that I have more whites and I have eliminated any of the blacks by eliminating the green. I can then slew that down, eliminate the reds which indicate my very bright areas, and increase the black areas. What we can do, again to demonstrate the auto video, is we can slew that brightness high. We can then press the auto video soft key, and we can see that automatically our multiplier voltage, our contrast, and our brightness has again been changed to give us a little bit of brights and a little bit of darks in that image. Again, optimizing for the best SEM image. To exit the video calibrate mode, we press soft key number 4, which is now labeled Stop Video Calibrate, and we return then to page 2 of the SEM menu with Video Calibrate now turned off. Let's return to our previous menu, or page 1 of the SEM menu. We have now gone through an auto video. We have re-registered the sample according to our mark on the TV monitor. We can again, using the fine focus, refocus the image. We are now ready to go to the desired magnification for the next SEM photo, which was a magnification of 500x. To repeat the photo procedure, we exit from the SEM menu using the soft key number 8, which returns us to our home bank. We then go to Setup Photo, which is Shift and function key 20. At this point, we turn on the desired fields, fill in the desired comments, also fill in the correct photo number, and take the photograph. What we will do is take photographs at 500x which is the magnification we are at right now, photographs at a magnification of 1000x, 2500x, and 5000x. This will then document the area for analysis. To obtain our last photograph at 5000x, what I would like to do is obtain that without going into the Setup Photo menu. We know all of the fields which we have turned on in the Setup Photo menu. They are all the same for all of the photos which we have taken. The photo number has automatically updated itself. So rather than pressing the Shift key and function key number 20, which goes to Setup Photo, we can press function key number 20 by itself. That will then give us the direct photo mode. The computer will respond by telling us to open shutter, strike enter to proceed. If we find we do not want to continue with the photo, what we could do is press escape to abort. Then we would not have to go through the photo routine. Pressing function key 20 also superimposes on the TV image what fields we have turned on. If we agree with the fields that we have turned on, we can then continue the photo by striking enter. If we do not agree with the fields, for example, if we have the wrong comment or the wrong photo number, what we can do is press the escape key, abort from the photo, and then enter the Setup Photo menu by pressing the Shift key and function key 20. Then we can change any of the comments, photo numbers, or fields which we do not agree with. As I had mentioned earlier, all of our photos were taken using the same comment. The photo numbers have stepped automatically. Photo number 101 was at 200x, 102 was at 500x, 103 was at 1000x, and photo number 104 was at 2500x. So photo 105, as is displayed here, will be our 5000x image. At this point, we can then open the shutter on the camera, strike enter, and expose the photo. Notice while we are photographing, again we get a message on the computer screen that says exposure in progress, please stand by. Since we are not in the photo setup menu, we do not have any of the menu being displayed, but only the message exposure in progress, please stand by. When the photo is finished, once again, we get a message, close shutter and strike enter. When we close shutter and strike enter, we then return to the home bank. We now have a series of high-resolution secondary electron micrographs obtained from the sample using the Phi model 660 system. Photo 101 depicts the sample at a magnification of 200x. Photo 102 shows the same area of that sample at a higher magnification, that magnification being 500x. Photo 103 shows the sample at a magnification of 1000x. Photo 104 was taken at a magnification of 2500x. And photo 105, which depicts the exact area where we want to do the Auger analysis, was taken at a magnification of 5000x. Going back to the TV monitor, now that we have documentation at 5000x, which is what we see on the TV, we want to make sure that when we do our Auger at this magnification, we want the exact same area. So what I will do is pick out a feature on the TV screen, and using a felt tip pen, I will outline that feature so that when we change the condenser lens and the objective lens aperture in order to get more current for Auger analysis, we can duplicate the exact same area that we have with 0.05 nanoamps of current where we took the SEM image. Going back to the computer monitor, we now want to take another look at our electron gun parameters, entering the SEM menu using function key number 17. We have all of the parameters optimized for the best SEM image. What I would like to do is store those parameters so that anytime I want the best SEM image, I can use my settings, which is function key number 1, and I can define these settings. This is the user-defined settings that we want to set up. What we can do is go down to soft key settings, which is our soft key number 7. And that allows us then to add a setting or update a setting. Since we have no user-defined settings at this point, we want to add a setting, and what it will do is take the electron gun parameters that we have, and we can give them a file name. Notice now that function key number 2 or line number 2 is asking for settings name. Since these are the settings for our best SEM image, what we can do is give a file name here of SEM. So I will type in a capital SEM and then enter. Notice now that my settings indicator, line number 1, shows that our settings that we are now using are defined as SEM. If we were to now go to initial settings, which, if you remember, are at 3 kV, and we then introduced a new sample and wanted to take a secondary electron micrograph on that sample, we would have those settings already optimized under this file name, SEM. We'll be doing this also when we start Auger data. We'll want to get probably on this sample about 100 nanoamps of current, and we will then, once we get all of the electron gun parameters set for 100 nanoamps, we will then give another settings name, a user-defined setting, and we'll call that AES 100, which will give us Auger parameters 100 nanoamps. Right now, again, we have now documented these settings for the best SEM image using these parameters, 5000x, 15 kV, with this focus, stigmation, condenser lens settings, emission voltage, and so forth. All of that will now be stored under the file name SEM. At this point, we would also like to utilize the Save Image feature, which is soft key number 4. That will allow us to take the SEM image and store it on the data disk. Before we can do that, we need to make sure that the directory is set to save this data, because this is actually the first hard copy or the first actual piece of data that we will be taking from this sample. To do that, let's exit the SEM menu using soft key number 8. We then want to enter the directory menu, which is using function key number 13. We can see that what is highlighted is called data. That means any of the data that we now obtain on this sample will be stored under this major file heading. What we would like is to create a new subdirectory, which, as you can see on the right-hand side, we have many subdirectories. What we would like to do is create a new subdirectory for this set of data. To do that, using soft key number 1, which is labeled Create Directory, it then asks for a directory name, and we will call this subdirectory Instruction. Enter. We now want to execute that command, and you can see that we now have created a new subdirectory from the main data file entitled Instruction. In order for us to actually use that subfile for the collection of data, we want to highlight that subfile. And to do that, we use the arrow keys located in the lower right corner of the keyboard. And by pressing that arrow key, I have now highlighted Instruction, so that any data that we now acquire will be stored under the subfile Instruction. We can now exit the directory using soft key number 8. We are now back at the home bank. Soft key number 7, labeled File Naming. By pressing that, we can enter the file naming menu. This will allow us to name the files, giving the sample file a prefix name. Also, the starting file number, which will then sequence from that number, and any comments that we wish for any of the data that we obtain. Since this is a microwave transistor, let's use a sample file prefix of MWT. Our photos were a 100 series photos, the first SEM photo being 101 and sequencing from there, so let's use a start file number of 101. And for comments, let's type in microwave transistor. Any data that we now obtain will have a sample file prefix of MWT. It will have a sequence file number in the 100 series, and the comment will be microwave transistor. Now that we have the directory and the file naming set, we can exit this menu and re-enter the SEM menu. Before we actually store this image on the data disk, what we would like to do is go back to the TV screen and make sure that we are in focus and registered to that mark which we drew on the TV screen. To make sure that we are in focus, let's first increase our magnification from 5000x, and in this case I will go to 30,000x. At that magnification, I will then obtain the sharpest focus. Let's now return to a magnification of 5000x. And if we need to register, we can use the image shift, which is function key number 3, and using the arrows in order to align the sample with our registration mark. Once we have that, we can then go to the Save Image soft key, which is soft key number 4. When we press soft key number 4 to save the image, we will notice that we will get the computer to update us as to how much of the image is being stored. Now that we are ready to save the image, let's press soft key number 4. Notice the computer says that saving of the video image has begun. The saving of video image is 25% complete. Saving of video image is 50% complete. Saving of video image is 75% complete. Video image is stored in file MWT101. We will now be able to call that file up, manipulate that SEM image, which has been stored on the disk, and do any image processing, which we would like to that file. This we will do later after we have obtained the Auger maps, but we do have that piece of data stored on the disk if we want to manipulate it later. Going back to the TV image, we see that while the video image was being stored on the disk, it has frozen the SEM image. What we can do to get a live image back is using soft key number 1, which is entitled Erase Image, and that will now return us to a live TV image. Let's briefly review what we have accomplished so far. First, we introduced a sample into the specimen chamber. We then obtained a TV image. Using the TV image as a guide, we located the sample and an area on the sample where we wanted to do the analysis. We then positioned the sample at the focal point of the analyzer. We chose a beam voltage at which to analyze the sample. We then optimized the electron gun parameters in order to obtain the best SEM image. Once we achieved those parameters, we documented the area where we will do analysis by taking SEM photos.